Welcome to our work, Transferring Cross-Domain Knowledge for Video Sign Language Recognition. This is a joint work of Dongxu, Xin, Chen, Las, and Hongdong from the Australian National University. Over 400 million people worldwide have disabling hearing loss and use primarily sign languages to communicate with others. However, most hearing people do not understand sign languages. As a result, great communication obstacles exist between deaf and hearing communities. In this work, we focus on word-level sign language recognition. In this task, we take video of an isolated sign word as input and ask the model to predict the category of the sign. The low resource issue is a major challenge in sign language recognition. To tackle this problem, we resort to a transfer learning method from cheaply available web data. We notice there are relatively abundant news broadcasts in sign languages, and the occurrences of sign words in this broadcast might be of usefulness in some way. Our method is about how to transfer the knowledge between this isolated word domain and the news word domain. We found that directly feeding the extracted samples does not necessarily help to improve the recognition. Instead, our method originates from a simple observation. Despite the domain difference, key gestures are invariant. Namely, if a gesture appears in a sample of domain A but does not appear in a sample of domain B, that means this gesture is not helpful or useful to identify the word. Here is the pipeline of our method. First, we train an oracle classifier using the isolated sign samples only. Then we apply this word classifier on the collected news broadcast videos in a sliding window fashion. We keep the temporal windows that are classified with a high confidence. Since the two video sources have a domain difference, we then combine the collected samples together with the original isolated word samples to retrain the classifier. By doing this, we expect the classifier to coarsely align samples from the two domains. Next, we organize the collected news samples as a network structure so-called prototypical memory, which is a collection of class centroids of news sign samples. We use the prototypical memory as a differentiable retrieval function. Specifically, we find the most correlated memory cell to the query feature of the isolated word samples by computing the pairwise correlation. Intuitively, we are forcing the network to learn the concepts that are shared by both domains. Therefore, we call the retrieved feature from the prototypical memory as domain-invariant descriptor. Finally, we use this domain-invariant descriptor to guide the feature learning on the isolated sign samples using an attention-based alignment method. In particular, we enforce the model to focus on the temporal regions that are aligned with the domain-invariant descriptor. We observe a significant improvement on two word-level sign language recognition dataset. Here, we show the recognition accuracy, the higher the better. We rarely show the temporal regions with higher attention scores as brighter, and select the frames with the highest attention as the signature frame. We can see the signature frame is consistent among different isolated word samples. We also demonstrate the capacity of our model by using it to localize sign word from sentences. The localized segments are shown brighter. As shown, our model achieves a better localization result on the word book in this instance. Thanks, and please feel welcome to ask questions.